like if at all we have to design an assembler, what should be the process? Fine. So for the same, we'll require uh, some mechanism rather to really find out what we will be requiring. So in previous session, rather we talked about some mechanism which was designed or defined in terms of count perspective. Okay, now suppose if I am given something like a code, okay, what would be major challenges in front of me? So let us try to take this one of the code. Let us take this code. So what I'm supposed to do? Can somebody point out? Like one thing is what our target is to generate an executable, or rather generate an object code for this. So exact machine representation for this code. What should we do? Yes. Can somebody tell me what would be required to translate this code to what we can call it as an object code? Hmm? What will you require? First mechanism is what? Convert this data, arrow data, okay, BSS in the form which is expected there. Correct? Which is expected there. Now what, how will you achieve that goal? Like if I try to say translate this code, I get this. So you may see like for this line till 10-0, we got this one, right? 41, 42 and so on till 5A. Similarly, when we see this, we are getting this translation. For digits, we got this translation. Maybe for symbols also, you can get information about what could be the possibilities to have maybe read this translation done. Similarly, if I see below, when I talk about some integers are given instead of what we can call it characters, we have to find out mechanism which will translate this number, say probably into 4 bytes and to be written in terms of what we can call it as Little Indian notation. Right. Now, if we have to do this, let us only target for a while these three things: data, R data, and BSS. And we easily can convert them into say ASCII value and so on by seeing exactly what we need to do. Okay, so that we would be able to see this, at least this kind of object code. You can start these addresses from 0, like the way that we have seen here. If you see this section dot arrow data, let's start here. Every section would be starting with 0. Okay, no matter which section you are talking. Even if we talk about text also would be starting with 0. Then how exactly it will be knowing that it has to consider this now as an text section or data section and so on. So if we have to achieve this goal, what would be required? What is to be done? So first thing is what we already saw in the previous lecture, like you could successfully read a file, okay, uh, which is given as an input probably in assembly code. Correct. If we can read that file, specifically find out what is the value assigned there. So we are going to take into consideration only two kinds of values, either a string or a number. Correct. So if I have to do this, what process do you think would be efficient or sufficient for you to convert these three sections into respective representations that we can see over here in front of us? What are the sections that are displayed here? What do you think? What will be required for you to convert these say what you can call it as these three sections? Hmm. Yes, what you have to do? Yes. Are you there? Can you hear me?
Yes, sir.
How will you achieve this goal? How will you differentiate between integer and probably what you can say string? Even the number of bytes to be taken into consideration. Correct? How will you do that?
Sir, strings are enclosed in double quotes.
Okay. Then what would be next thing? For integers or what you can call it as numbers. What will you do? Now, one thing that you are going to target is what is the declarative statement used there. So for a string, you will always see DB, correct? The way it is shown. For numbers, it could be double word or even DB sometimes, because if you see a message to DB, we saw 10 and 02. So these are numbers. So if it is not string, then we have to see how many bytes you are requiring to convert this. So first mechanism is what? If you are given a number, can you convert it to hex? So you have to write a function probably, or you have to use a ready function, which would be helping you out to convert given number into hex so that you can use that function and write it the way that it is shown. So if I talk about capital A, then I know that it is 65. If I give that 65 as input to my code, or even if I pass this character, whatever the character that I'm reading to hex as an input, say in a ASCII as character, it should be able to convert it to 41. So whether you are going to pass a character or you are going to pass its ASCII value, be dependent. If it is a string, but whenever it is a number, then you have to definitely use some mechanism to convert it. Another aspect is you have to organize it in the manner it is written here. So you are going to write two routines. First routine is what? Our first function would be what? If it is a string or a character, then how exactly you are going to display in hex? And if it is a number, first thing is convert it to hex. Second thing would be what? Write it into Little Indian notation. So these would be the two routines that you will require there. First is convert the value into hex. So that can contain two kinds of arguments. One argument can be a character, one argument can be a number. So you can have an overloaded function, correct, which will convert that input to an ASCII value. Second thing would be what are the number that is given to you, depending upon if it is double or a word, then it is to be organized in Little Indian notation. So you can see how exactly that number can be converted. So if I take example as 1, 2, 3, 4, 5, 6, 7, 8, see how it is written. Correct. And even I passed few links in one of the previous class about that Little Indian notation. Okay, so you may see that in maybe comment window of this particular lecture, I have added an assignment which you have to complete. Okay, by tomorrow night. Fine. So instead of 12 a.m., I will say 12 p.m. because in afternoon time, like in the night time, the machine doesn't function. The Moodle doesn't function. And I have made the change appropriately. You have 2 days to complete this task. Complete this task and get the conversion done so that the next thing can be proceeded. So next thing would be like you are going to write small routines which you are going to reuse later in the complete conversion. Then secondly, if you recall, once I assume I gave you a task or I asked you to think about how can you convert that to mod RM, and you already wrote it. 47 of you already submitted a program which reads a file containing only operands for assembly instructions to generate mod RM byte. So you can use that code, okay, directly here to read that instruction and convert it to mod RM. So every operand would not be or converted to mod RM byte. It depends on what is the type of the instruction. So whether it requires mod RM conversion or not. Right. So considering this, you will see that there are small components which you are going to organize together at the later stage when you are submitting it as an assembler. So if at all I have to think of designing an assembler, what would be different components that would be required to be used by me rather. Fine. So let me share the screen. So that we can work out. By side would be drawing main components that would be required by us rather to generate this assembler. So apart from the regular routines that you would be seeing or which we discussed like mod RM and kind of conversion, we definitely will require some kind of mechanism. Okay, so let us try to first talk about main components of your assembly code. So our target would be what? We have to generate an assembler. Okay, where there would be say you can say there would be many components included which will be kind of input for you. So suppose this is my main program for assembler. Fine. Now this program, through this program, you are going to read probably what you can call it as an input file. Correct? An input file, which would be a source code for you. So let me say that I am going to read a source file. I'm going to read a source file. Now this source file, when I open that file, I'm not going to convert it all together. I am going to read it line by line. So you are going to read the code, okay, one line by one line, and then you are going to take that line for processing. So let me give some name to this as You are going to read that line by line. So suppose you saw, you got to know first line, then you are going to distinguish between the components. So if I talk about assembly code, so initially what we saw section.text. So we saw section, we saw text. Maybe we can see section.data, section.bss, or even a semicolon. When I talk about semicolon, ultimately what is to be done with that semicolon would be another thing. So when you are going to distinguish between all components that are available, correct, that are available there. So you are going to definitely carry out distinction between each word, correct, and that is called as collecting lexicons. In general, you can say lexical scan. So you are going to collect lexicons. Now these lexicons would be kind of components which would be there in your file. Okay, for example, section, then text, then data, then global, then main, and so on. And then, like when you from where you are going to collect these lexicons from the source file. Now these lexicons would be taken and given as an input to your program. Correct? To your main program. Now, while you are reading these lexicons, you are going to verify whether what kind of element it is, whether it is an identifier, whether it is a directive, whether it is instruction, and so on. So let us have a routine defined here. Okay, this would be we are going to define a function, okay, which would be reading elements from the table. So you can have separate ones or you can have a single routine. Only your input table would be modified. Okay. Now, what would be the possible input tables? Is you have instruction table, instruction or opcode table, which you are going to read. Okay, now when you are working with this, ultimately you will see that you are going to read the program. Okay, collect the lexicon, find out whether its entry is possibly here or not. Now you are going to send a return message to yes, I found it or I haven't found it. Correct? Now, if you are talking about an opcode, it is you are going to verify from here. Correct? And then you are going to return back the message to yes, I found it. I haven't found it. Now, this was with respect to an instruction if at all it is there. Second data structure possibly could be directives like global, section, correct? Then text, data, and so on. Correct. So you are going to apply the same procedure here too. Correct. You are going to read, you are going to communicate. Fine. Now you will have another third one, which you are going to call something as symbol table. Correct? Symbol table. Now this symbol table would be responsible to hold information about all variables, labels, function names, procedure names. All of them would be collected over here. You are going to check it whether it is part of symbol table or not. You are going to communicate whether yes or no. Now, whenever it is no, there is some problem with either of these. Problem in the sense you tried searching about, but you could not get it. then you are going to find information or display information from error table. Okay, so you are going to search the entries in the error table if I can display some error, and this error would be picked and communicated to the system. So somewhere we are going to communicate it. Say for example, let me draw something like this. If there is no error, okay, from the main code, then we saw that in the code, we saw that section.data starts at 0. Section.text starts at 0. Section.bss starts at 0. Section.ro data starts at 0. So who is going to point out it? Somewhere we will require some kind of mechanism, okay, which would be acting as something called as location counter or program counter. So let me write PC or LC or instruction pointer, but this would be only when I say IP instruction pointer, then this looks to be only for program. I mean to say .text. How about section.data? So do we require maybe specific kind of counter for each of these sections? Probably yes. And that would be increased, like increased or decreased ultimately, depending upon what action is taken. Whether we are going to use it or whether we are going to not use it. You are going to definitely use it depending upon what is the scenario. So I'm drawing this in general. Now I haven't specifically said which kind of assembler I'm implementing right now. Now if everything goes well, suppose there is no error, if everything goes well, then it is going to generate something as like, because see, you have to collect mod rm, you have to collect conversion of assembly code, sorry, conversion of instruction by opcode, you have to collect conversion of element from data section or a literal table or few other things. So when I wrote symbol table, there is something hidden behind too, right? So it would be what we call it as a literal table. A literal table. So this would be your literal table. And this literal table would be used any time whenever you see that there is a constant number used. Say for example 10, 0. What is the source line that we saw earlier? So these all needs to be considered through the conversion factor, because how will you make sure that how the number is to be represented? If it is a number, the number needs to be represented in hex. But next thing would be what? How many bytes you are going to take? How many bytes you are going to take? This would be really important. So this would be taken into consideration, that conversion through the literal table. Another thing, like when you are done with first instruction, so you are going to say I am going to generate an object code line rather. I should not say object code, but converted assembly line in object code form. I should say form. Correct. And now this would be written every time. And it is going to repeat this process until you reach to the final instruction of the code. So when you are done, ultimately each line needs to be written in terms of what you can call it as an object file. So I'm going to get check code, and this would be written once my translation is done. If errors are, then ultimately errors also would be written in some form by this process only. If one error is there, it may or may not generate an object code, because every time that error may not be an compilation time or translation time error. It could be a what you can call it as runtime error too. We don't know what kind of error it is. Correct? What kind of error it is. So if I see, I can think of a picture how my routine would be, how my program would be. Now there are small components which I said when I say convert assembly code through the main code, main program. These are the different things that we are going to talk about. Say, for example, opcode table, directive, symbol table, literal table, and so on. But when we do talk about computing next address of data element declared in BSS or data or RO data, also the address of next instruction, these all things need to be managed through the small routines which may be part of your main program or which are called through an API that you have created or a library that you have created. Code library. Now, when you do so, you can think of some kind of picture as an outcome perspective. Okay, what I would be getting, what I'm expected to carry out. So these would be kind of main operations which might be included into your program. So depending upon whether you are talking about one pass assembler, two pass assembler, there would be something involved somewhere here, pass indicator in main program, which I haven't written anything about right now because I am not sure what kind of assembler I meant to implement. What kind of assembler I meant to implement. But this would be kind of what you can call it as summary of most important components or operations included as a part of assembly design or assembler design. Now, when I say this, what would be involved? What other factors would be involved there? Like when I pointed out that mod RM to be converted, errors need to be catched. How many different errors you can think of? Rather, I haven't given you rather code or something to write for, but you can think of. I might have said that I don't know how many errors you could catch up. Write a C program where that C program should not show you output, but C program should show you different kinds of errors. No error should be repeated. Now, I assume most of you must have carried out that activity, or if you haven't, try to carry out it. You can think of any other programming language tool. I don't mean to only make use of C code. Now think of from where the text is catched. What are the text that is shown to you as an error perspective when an error is shown? Say for example, if I take this code, let me modify this code a bit. Suppose I remove these double quotes. And if I try this thing, it says comma expected after operand 1. Now, the thing is, if I add comma after operand 1, so what exactly it is trying to tell me? It is thinking this as a number. If I add this comma, let us see what it shows. Comma expected after operand 2. Now error is changed. Let me add comma. So if I give along this comma like the 1, then when I add that for G, we know that A, C, D, E, F are taken as ASCII value here. But when it talks about G, let us see what it shows. How many commas I am going to add. So is it consider? Let me add all commas there. H I J K L M N O P Q R S T W X Y Z. Suppose I convert this, like if I add this. Now symbol A undefined, it is not ASCII value. Because simply writing A doesn't really say that it is an ASCII value. But if I write something here, let us see, is there any change? Expression is not simple or relocatable. Now you can see I'm trying to show you different errors. Different errors. That's okay. Let us try to make the change. Let me write like this. Now symbol C undefined because after A, C was there. So if I add 0x, 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 0x. Now if I try writing 0xg, we know it cannot be part of. It simply says expression syntax error. Now you can see I have showed you many errors there from where this text is coming. Now say for example label, error label, change during code generation. Only this thing is to be changed. Only this thing is to be changed. Rest of the error is same. Same case here, comma expected operand after operand 1, comma expected after operand 2, comma expected after operand 7. So what is changing there? So some part of text from the error message is same. What is changing is partial representation of that error. That means what? The error table that I am talking about would be containing the fixed text. I need to really collect information at which line that error should be shown. So I can think of, suppose if I am assuming that there is an error table, say line number 7, line number, sorry, error number 7 is this, comma expected after operand %d. Example. So what I will do, I will write that into some temp error table. I will write line number 2, 2, 7. Now the 2 refers to your assembly code and 7 refers to that error main error table where all errors are error text are written. So I'm going to create this. Correct. So let me go back. Let me delete this. So if I write, say, for example, suppose I write A there. Now you can see that it is showing me directly line at 11 number. error at line number 11. So if I go back and check 11 number, it is showing me this. So if I use comma, now my errors are changed. Now see, some errors are same, some errors are different. And even the line numbers are differing depending upon what exactly you wrote. Correct? Now it is not talking anything about this move instruction that it doesn't have or it should not have more than 2 parameters. It is talking that symbol DFG is undefined. Okay, let me define that DFG. Now you can see when I added that DFG, it says now like error to be different. Array it was symbol DFG undefined. That means it somewhere got information about DFG into symbol table. Into symbol table. So I will require first to think about these errors. Second is to how exactly I'm going to populate my symbol table. How exactly I'm going to populate, made modification into the symbol table structure that I have created. Now, how do I assure myself that these routines are written by me so as to capture information from my source code? Correct. So try to gather few small errors, small set of errors. Now think of an assembly code which will compute a factorial for you in a normal manner. You can think of an instruction which adds probably two numbers together written in data section. Similarly, think of you are going to multiply two numbers, you are going to divide two numbers, you are going to subtract two numbers. Take these minimum operations and try to generate as many errors that you can and collect that information about those errors and think of mapping it in terms of some data structure which you will be calling as error table. So two kinds of error tables. One error table is collection of all these errors. Second table is mapping with respect to the program. And that first table is static table. Error table is static table. Program error table is a dynamic structure where you would be picking line number. You would be picking line number and you are going to write what you can call it as the error text. But error text you are not going to write every time. Towards the end, you are going to write that error text, because otherwise you are going to collect that like the way that I saw here. Errors are shown like this. How do you get this dynamic table generated? Now you think of collecting first the symbol table. How do you collect symbols from the instructions or a code that is written? See, errors would be different. Errors will have their own form depending upon what errors you are considering. I have given you sample code. Sample program would be what? Addition of two numbers, subtraction of two numbers, multiplication of two numbers, division of two numbers. calculating a factorial, right? Verifying which one is maximum in respect of the number, two numbers given, minimum from the two numbers. Take these sample codes, try to write them in assembly, try to assemble them, generate assembly code. I want you, sorry, generate LST code for it, and I want your code to convert that to the form which is shown into LST. Addresses may differ. I'm not concentrating on what you see as address. So I'm not talking about addresses in the sense. Okay, let me correct this so that I can show you what I'm expecting there. Awesome. Oh. I want you to generate this code. If at all it is to be done, what exactly it did. So let me only talk mainly about our main function. Yeah, I want you to show me this. But when I talk about showing this one, moreover, yeah, see, I am not interested in these addresses right now. You can take local addresses starting with 000 as an output perspective. Now, here you might be saying that I'm talking about code, but it could be important for your data too. For example, somewhere you would be saying in LST only. How these numbers are to be generated. You have to add line numbers as well in the code. This should be the output shown. Now, how you are displaying it is your own design or your own decision. How exactly you want to display this. But I want you, initial stage would be what? You can see the assignment that I added right now on Moodle. Okay, and which I shared rather into chat window. It was with respect to data, arrow data, DSS. I haven't said anything about this dot text yet. Let us not concentrate on dot text. But ultimately, when you are reading this message one, if I try to gather, say for example, if I remove this and I fire this read elf dash s. This is my symbol table, and you can see that everything which I declared as a label, everything which I declared as a function, everything that I have declared as a data element is added here. So now what form you are taking, I don't care. You decide. We discussed earlier too, what should be the things. But I want you to come up with a symbol table architecture or symbol table structure. Okay, how do you get it? How do you get it? So for a reference perspective, say I'm adding for your information from the manual, like which is available on Oracle site docs.oracle. You have to think of that symbol table mainly. Okay, from there, how exactly the symbol table is to be picked. If at all I have to go along finding out information about such a table, correct? How do I get it? Because it would be mandatory for us to understand what symbol table would be containing. Correct? What symbol table would be containing. You can pick any good standard book. Yeah, any good standard book for a reference book for NASM. Okay, and use it. And use it. Now, when it is to be done, how exactly you will map it? How exactly you will map that symbol table? Now, if at all I have to map that, then I will require how exactly my translator will be taking help of this symbol table in the front manner. So if you see now the latest one, which I added there as a link, it will tell you what a symbol table can contain. So though it is talking about other things, but you will definitely require some structure like the one it is shown. I don't expect you to implement similar structure, but I want you to really target how can I get that symbol table in a form. Now we saw that I can see the symbol table through readelf-s, or I can see that symbol table through this nm command as well. And you can see that same numbers are repeated there. Say for example, A4 is at 9, A4 is at 9. Let us see DFG is at 0, MHG2, MHG2 is at 1C. Same thing is picked there. It is qualifying them in respect of which section they belong to. Which section they belong to. Because if at all I have to add entries there, I definitely will require some mechanism which will help me out to add entries into this symbol table. Right, because only describing or deciding symbol table structure doesn't help us. It should be implemented in such a way that it should be very easy for me to search to add entries into that symbol table. So when we discussed about which data structure would be efficiently good, we got to know few inputs from your classmates or batchmates. There are so many mechanisms that you can think of depending upon the programming language that you are using to translate the code. To translate the code. It would be important for us to gather information about all symbols. Now what would be their types? We saw that they can occur into symbol, into text section as an a name of a procedure, as an a name of a label. When I say procedure, it could be a function like extern printf. If I include that printf here in my code, if I add it here, suppose I am adding these two names, and if I generate, and if I try to see, you can see main printf and my mex is not found. That's why it is saying undefined. Somewhere we will require that column added there, whether it is defined or undefined when it is referred. Now, how to build symbol table, we'll be talking probably next lecture on Monday by taking one example. So till that time, I expect you to define what would be columns of a symbol table, probable columns of a symbol table. Okay, as well as I want you to be ready with respect to that conversion, which I have added as an assignment for you on Moodle. For dot text, sorry, for dot data, dot BSS and dot RO data. For data and RO data, method is same. BSS, it is a little bit different with respect to what you see here. For example, if I say this process of conversion, the process of conversion here differs. So this number is going to tell me how many bytes are to be reserved. So 1, here it says 1, but it is a word, that's why number of bytes are 2. It says 1, but size is double, that's why 4. It says B, bytes are 2, that's why 2. It's a B, 4, that's why 4. So like you have to only formulate mechanism for two sections, data and BSS. Right? Data and BSS. Because you already have mechanism defined. I'm assuming that you already would be having mechanism defined for one of them, either a RO data or a data part. So you may not require to write two different procedures. Only thing that you would be required is to differentiate between data elements, data types, whatever the types that are available in between. Any questions till the time? If you have, you can ask me.